Alright everyone, welcome back to another episode of Get Your Tech On, the show where we'll dive into all things DOCSIS and cable tech. I'm Brady Volpe. Joining me, as always, is the legend, wait for it, Derry John Downey. Today's show is packed with the latest from SCTE TechExpo. We'll be covering what's new with DOCSIS 3.1 and DOCSIS 4.0. We'll discuss some of the live demos seen at the show floor, including real-world speeds of 9.8 gigabit per second down and 3.7 gigabit per second up with DOCSIS 4.0. We're also going to dig into the new vCMTS that one of the vendors had, AI's growing impact on cable industries, smart auto balancing amplifiers, and a future of equipment that we're going to see with DOCSIS 4.0. And if that's not enough, we're going to dive into some of the technical papers from the show. So lots to get into this episode. It's going to be legendary. So, John, good to see you. It feels like it's almost been 2 weeks since I saw you face to face.
I hope you're not lactose intolerant. It's going to be legendary.
Lots of dairy in our show today.
And happy Columbus Day / Indigenous People Day on Monday.
Yes. Happy long weekend if you have it. So John, we're gonna.
It was good to see you guys. You and me and everybody else at the SCTE Expo in Atlanta. I think it turned out to be good weather till the very end, right?
Yeah. I got a lot of rain, a lot of wind at the end there because that hurricane that came through. So hope everyone was safe on the first one and on the second one that hit Florida. So it was some tough times the last couple weeks for a lot of people. So, John, I thought we'd start off with a short video recapping SCTE Expo. For those of you who are there, you'll see some things you saw. For those of you who won't, you'll get kind of an overview of what we got to experience. And then for those in your chat room, username redacted, good to see you. Mr. McFreeze, good to see you. Noisy Ando1, good to see you. Thanks for joining, and feel free to ask us questions as we go through a recap of all the tech that's that is here now and also coming up available soon. So starting into this video, one of the things you'll see right away, 1996, Atlanta hosted the Olympics. So the Centennial Olympic Park, you see the show, lots of things from the Olympics there. Then the first thing we hit was this long line, the registration longest registration line I ever saw for Cable Tech Expo.
Yeah, I don't know what happened there, what the logistics were, why it was so much different than previous years. Before we go into kiosks, we check yourself in, and they said a lot of people had a barcode you could scan and go through quickly.
Yep.
But I don't know. The line kept getting longer and longer. I told the line, I'm like, well, let me get something to eat. It'll die down. I come back, it's twice as long.
Yeah, it was like an airport security line.
After a while, it was long, but it went through quickly. But it's still just, I don't know what happened compared to other years.
Yeah, it was definitely something different, and there weren't as many people, I don't think, this year compared to previous years. So the line was interesting. But I think the next thing I have up here is the panels. So of course, the workshops and the panels are something that a lot of people pay extra to see. You have to get a full exhibition pass to see that. But this is what one of the panels looks like here. We have a short snippet of that. I'm introducing Larry
active
Wilcox.
with SCTE chapters, the Expo Program Committee, and board member for the SCTE Foundation. Larry, take it away.
So these panels are very common in the way that we do that, where you host. Typically have 3 or maybe 4 presenters and a moderator, and then you talk. The presenters talk about different technical things in the industry. Typically, if it's a cable operator presenting, they're going to present on what they're doing. I'll be talking about one of the lessons learned papers that Rogers did shortly on their vCMTS. There's a lot of cool lessons they learned about that. And John, I know you have some papers that you're also going to cover in there.
So this side of the conference floor was called the loft. Right?
Yes. So this is one of these ones are done on the floor.
The other side of the floor was called what? The Innovation Center or the...
I think it was Tech Talk.
Tech Talks.
Tech Talk.
Yep.
What I did like about it was, one, it's free. Like, you didn't have to have a full pass because it was on the show floor. I didn't like the fact there wasn't enough seating. Would have been nice to have maybe more seating.
Yes.
But it was quicker, precise presentations, which as a presenter I never really like because I need time to set shit up. But it was like to the point. Like on your panel, you might have had 3 guys, but they all had maybe only 10 minutes each.
Yeah,
like,
or a maximum of 15, and then with some Q&A at the end.
Yeah, so it was quick. It was to the point. It's like, all right, so you're not, when you go to a normal workshop, it feels like you have to commit to like an hour and a half, and you're stuck there on something maybe you didn't know what you got yourself into.
Right.
Like, man, what do I do? Look at my phone the whole time, or just get up and walk out?
Right. So you're actually talking about this one that was done on the floor that we're looking at right now. This was actually P&M Live. So the one on the floor, we actually only had 8 minutes. We had an 8-minute video we're showing here. You can see the audience is absolutely riveted getting ready for this is a setup for my video here. And what P&M Live is, and I have a link in the bottom, there's you and Mia there getting ready for my video. There's a link in the bit video or in the notes below, but this is showing using P&M to troubleshoot real problems, real impairments out in the field. And I think that's why people like this so much, because what you're seeing right here, when the guy is squeezing this coax cable, there's water dripping out of this drop cable here. And that was something you can, as it says in the bottom, you can see the water coming out of this piece of coax cable. Video link in below to see this whole 8-minute video of technicians using P&M to troubleshoot real plant impairments in the field. And I think that's why these are pretty cool to see that. So to your point, though, they're only 8 minutes long each video. It's really fine-tuned and shot in, tightened up. So there's no wasted time in that 8 minutes, because we fixed 5 impairments in 8 minutes.
Yeah, it wasn't a lot of fluff. You got right to the meat and potatoes of it, which I enjoy and appreciate.
Yep. So here's me with a colleague of mine, Hunter. Hunter is he's getting into the video production for one of the SCTE chapters. I think that's something the SCTE chapters will be great at doing, starting to do their own videos. We're kind of sharing stories here about what's the latest and greatest video equipment out there to be at the shows. And of course, staying downtown before the hurricane hit. Lots of things to do in the evening, nice nightlife. Well, we always have social parties in the evening. So if you attend Expo, you get to do that on the show floor. There's cool things to see. The people with real muscles, John. Look at the muscles on this guy.
Real John. Look at those calves.
I saw that too. I'm jealous.
And then, of course, at the show, you have all the cool equipment to see. So there was we're not just talking about 1.2 and 1.8 gigahertz equipment now, RF equipment. It's out on the show floor, but when you talk to the vendors, they're actually shipping this stuff out to cable operators now, and it's getting installed in the field. And I think that was, from my standpoint, pretty exciting to hear that this stuff is, getting some traction. Technicians are starting to get their hands dirty with seeing how this performs.
Also, a key point I think would be these manufacturers, vendors are providing solutions to existing housing. So instead of having to provide a housing and cut it out and replace, they might be able to keep their spacing and put a module in an old C-Core, SA, Cisco, Motorola housing, right? So I don't have to change out the housing at all, the heat shrink, the connectors. I might have to change out the Caesar screw mechanisms to go to 1.8 because of return loss issues, but the module will be plug and play.
Right.
And then we talked about smart amplifiers down the road.
Yeah, and so smart amplifiers was definitely something that I think just about every vendor had in one form or another, where they're not going to have pads, they're not going to have equalizers anymore. That's all going to be remotely controllable, so these amplifiers can be auto-balanced, auto-aligned, auto-tuned basically. And then they even start to talk about AI in these amplifiers, how if there's some sort of problem in the field, that AI can detect that and then automatically compensate that. So we talk about pre-equalization, how that's done so much in the upstream to compensate for impairments. They're looking at AI to do sort of the same thing for amplifiers moving forward in the future. And there's a lot of socialization. We see a lot of friends. Then the hurricane started to come in, and the night skies started to get dark and dreary, and a lot of people took early flights lights out of the show. So that caused the population to go down.
SCTE TechExpo24.
This was actually
We got everything we need. We got cameras, we got mics, we got the producer. Not only do you got mics, and we got lots of people to talk DOCSIS.
So that was that was a College Football Hall of Fame where we were talking about our next live stream that we're doing now. This was my colleague Santhana Shari. He did a supercharging proactive network maintenance by leveraging generative AI. His talk was really about how we're leveraging AI to boil all the first to be a help desk for technicians. To help them understand, ask what is group delay, and that AI engine has been really it's been trained. It's called a RAG model, but it's been trained on all the technical papers that we've done in the industry, so it can answer those questions to technicians. But then we're going to continually drive that into proactive network maintenance. So eventually, you'll just be able to type in a MAC address and say, what's the problem with this MAC address? And then AI will be able to come back and say, well, it has too much group delay or it has too much micro reflections, and then even go further to say this is caused by something out in the network and help direct them to where that network issue actually is.
I think the key is being proactive and being able to target and pinpoint where the problems are instead of wasting time, right?
Yes, absolutely. And just we're pushing so much information at technicians today out in the field. It was easy with DOCSIS 1.0 or 2.0 where you only had a couple of channels. Now we're adding more and more channels, more and more information, and expecting technicians to learn this very, very quickly. So what we see AI doing is really just being a sort of an assistant to the technicians to help them understand it, help them go through that, parse that information out very quickly, and then be able to start making decisions on, where do I go troubleshoot this? How do I understand what to do there? So taking a couple, lots of questions coming into the chat room here. So just want to take a quick look at what's going on here. So got a lot going on here. So thanks, Mia, for scrolling up here. So Noisy Endo, he says, I saw the Aurora Borealis yesterday. I actually saw that in my news feed that it was going to be even visible down south. So I've got to see if it's visible in my area as well. Mr. McFreeze, do you guys know if Rogers Cable is doing DOCSIS 4 anytime soon? I'm in the tech field actually working right now as I stream this. So I don't know the answer for that. We'll see if anyone else has that in the chat room. I wish I had training on P&M. I can't find any documentation on this program. Mr. Freeze, let us know who is your P&M provider. Grab a sandwich. Freeze, are you in Shaw territory? Tried looking on the pipe. Speaking of DOCSIS 4, I think there was a press release that they're launching it soon. Wonder if the plant is good enough, LOL. So, Mr. Freeze, yes, sir. I guess you're on the pipe. Grab a sandwich. He's a contractor in Winnipeg. Matthew Horit, welcome. You got to be careful with pin length when switching from 1.2 to 1.8 gigahertz with mod swaps. So, yeah, the higher in frequency, definitely center seizure and pin length that's really going to make an impact. A lot of things are going to make a big impact the higher in frequency we go to. So, Mr. McFreeze, you're now in Rogers territory. Welcome. Grab a sandwich. Shadgers. Mr.
A lot of the Caesar screws are now, Caesarless.
Yes.
So they're almost like the Chinese finger puzzle where it tightens down as you screw it in. And it's maybe 360-degree contact. So it's not just a screw tightening down onto a pin.
Yeah, they have the spring in there. We saw those at the show, a spring that automatically captures it when it goes down on. So it's you don't have to worry about forgetting to tighten the seizure screw or over-tightening the center seizure screw.
Yeah. Or undoing your connector before you undo the seizure screw and then breaking the pin inside.
Yep. They call it reactive network maintenance here because it seems like the plant is not very healthy in many areas. But what do I know? Grab a sandwich. I like that. Actually, a lot of people use P&M reactively, so that's not too uncommon that we see that. And Mr. Freeze says, not sure. I use P&M, but very limited because no one ever went in deep with the software. I wish I could learn more about it. And Mr. Freeze, I contract as well, so not sure where to get the documentation from. Okay, so definitely we need to get some P&M training out there. So I think, John, I think we have up next, if you remember, we did a short video in the vCMTS booth on our new CMTS. I think that is the next thing up next in this video stream here. There was just a couple more pictures here. This was evolution. This was on the more on. So we did see some 3 gigahertz plant equipment out there, and yeah. So this was the other booth that we were talking about there, right when we ran into Carthage and SOF, some more Cable Labs and Comcast people.
Pause there for a second. I ran into Carthage because he was looking for someone to join his team for DOCSIS, and he informed me they finally did find somebody.
That's right.
They have someone on his team now that will be the DOCSIS point of contact, maybe.
Yep.
I said that's good. Yeah, I said I really want someone that knows DOCSIS to be in there because this is Cable Labs. They're the ones that should be the top of the line and testing this stuff out and having the ideas of what to test. You know, how is this going to be deployed in the real world?
Well, let's hope they keep them because we need good people at Cable Labs. I totally agree. So this Entra vCMTS, this is a new vCMTS vCMTS. They also have an RMAC PHY. We got some really good details on that when we were talking to them, and like I said, I think that video is up just about next, coming to the end here. Oh, this is and actually we did stop by the Technetics booth where you're consulting for. Got to see some cool equipment Technetics had, also a lot of things there, and then we stopped by Bo. Bo's always a staple every year with his equipment. He did.
Hi, I'm Brady Volpe. We're at Cable TechExpo24, and I'm with John. So, Doug, we're at the vCMTS booth here. What is new at the vCMTS booth?
Other than the hurricane, we're showing off our vCMTS. So we have it running here on the server here, but it's fully cloud native, fully available in container environments. We're running Turbo 3.1, so this is 3.1 with OFDM and OFDMA connected to a DOCSIS 4.0 cable modem. So we're doing 9.6 down, 1.4 up, fully saturating the OFDM channels. And
5 downstream OFDM blocks.
Yes.
And 2 upstream OFDMA blocks.
Yes. Yeah. And then as well, also running on our vCMTS, we have DOCSIS 4.0 UHS 396 running here. And so again, 9.6 down, but in this case, it's 3.7 up.
Awesome.
So you just increase the upstream from 204 megahertz to 396.
Yeah.
And throw in an extra
block?
3 more extra blocks.
So in terms of the downstreams, the same number of OFDM downstreams right now that will be going up in a future release. But we've shifted them from the 1.2 gig to 1.8 gig. And so they're now running in the extended spectrum DOCSIS area.
The upstream,
we're doing 4 OFDMAs up.
Nice.
Yeah, and that is the UHS 396.
And that's utilizing existing newer CPUs, right?
That's a DOCSIS 4.0 CPU.
Yeah, and they're not available mass production yet. Right?
You'd have to talk to the kid modem guys about that.
So that's awesome. These are amazing speeds. 9.6 gigabits per second down, 1.4 gigabits per second up. What is your high-plex filter frequency split that allows you to achieve these speeds?
So in this one here, you can see that we're using high split at the 204, and then on the DOCSIS 4, then it's 396.
Right. So 396, we're hearing, is kind of like that sweet spot for the diplex filters for DOCSIS 4.0.
Yeah. Yep. There's a lot of interest. We've seen a lot of interest in the 396 split. It gets a lot more downstream available for subscribers, and then bumps up that upstream availability as well. So it's a really good sweet spot in terms of DOCSIS 4.0, but there are a couple other options that some operators are looking at.
Outstanding. So very exciting to have a new vCMTS on the market and available for operators.
Yeah.
That's awesome. Fantastic. We'd love to have you on live stream sometime, maybe to talk even more about this. So great information.
Okay.
Thank you so much
for stopping by.
Thank you.
Thanks.
Thanks.
All right, and that was the vCMTS CMTS, John.
You can pause that real quick.
Yeah.
So let's re-verify or validate what we were saying there. Is the The left side was they're calling Turbo 3.1. Some people call it 3.1 Enhanced.
3.1 Extended.
Yeah, Extended, Enhanced, whatever. But it basically is a 3.1 modem with a 204 upstream and a 254 to 1.2 gigahertz downstream.
Right.
So it's really getting 3.1, but they put a chipset in there that could demodulate and modulate more QAMs, more OFDM, OFDMA. You know, the 3.1 modems on the market today, well, last week, 2 weeks ago, whatever, was 2 downstream blocks, 2 upstream blocks, and a bunch of single carrier QAMs. And that was it. Even though the CMTS and your plant could handle more, doesn't mean the modem could. But now with this extended modem, it could maybe decode 4 or 5 downstream blocks. And if a block can get me close to 2 gig, 5 blocks is close to 10 gigabit per second. That was that sweet spot we're trying to push, is 10 gig, the 10G evolution, right? So 10 gig down. On the upstream, because of 204 megahertz upstream, we're limited in spectrum. 2 OFDMA blocks, we might be able to offer a 1 gig service. So if I want to offer a 2 gig service, I got to do something different. And that's where 4.0 comes in, by extending the diplex further out or doing FDX.
Yeah, and I thought they were also using, I mean, you can also use a 4.0 modem. And I kind of thought that is what they were really promoting, is saying, you know, we're going to be using DOCSIS 4.0 modems with a 3.1 extended CMTS. Because the 4.0 modems are really becoming available now.
By how much?
Yeah. So you're going to have a bigger price difference.
If it's unified DOCSIS 4.0 unified, it has to support ESD and FDX. So it has to have echo cancellation.
Very expensive chipset.
Yeah.
4.0 modems.
So I'm sure it's going to come down to money, and maybe people could buy it with a license or something.
Right.
Where they don't pay for some things that aren't used. I don't know.
Yeah, and so that's going to be a cable operator choice of, you know, do I go to DOCSIS 4.0 or do I just stick around for a while on DOCSIS 3.1 extended? Because that buys you a lot more runway. A lot more discussion in the chat room here. Many smaller operators don't support upgrading to those modems. Jason, Rook, good to see. All great feedback, and we need to fix that. Grab a sandwich. A lot of warning messages in Open Vault don't make much sense to me. We'll need to look at those. Keith Saar, I've seen older DOCSIS 3.1 modem firmwares have instability once upstream PMA was activated for OFDMA. Yeah, we've definitely seen that too with older firmware. Noisy and 01. I'm assuming that cable operators are planning on doing 25G PON. Yes, that is definitely in the plan. That's already on the roadmap after XGS PON. Keith, I saw someone say the same thing, that modems often start dropping to readjust or whatever, may worsen with dual OFDMA. Yeah. Got nothing on that. You have to talk to the modem vendors there. Many smaller operators don't support upgrading customer-owned modem firmware, and that's a problem number one. So that is definitely a problem. You know, customer-owned modems. I need to make a video on that about should you buy your own modem. It's for these reasons. Maybe bigger operators like Spectrum provide 3.1 modems at higher split modem market. So definitely cable operators, you know, basically saying you must buy our modems. It makes it much easier for them to support the firmware. Because if you're unable to upgrade the firmware in your modems, it's really problematic, particularly with DOCSIS 3.1. When you're trying to deploy OFDM and OFDMA, you need to be running the latest firmware. KJ Tech says, or possibly why Comcast has a short list of modems that they will provision OFDMA. To be certified, because those modems that they are shortlisting, they know they can upgrade the firmware, and they know supports that will reliably run on OFDMA and also OFDM in the downstream. Grab a Sandwich says, if we get 204 megahertz, that's going to be fun, because I'm still finding 42 amps LOL. Now the 85 amps will be obsolete too. But don't forget to Grab a Sandwich, you're going to have subscribers who have house amps that stop at 42 megahertz. So that's going to be just yet another problem you have, even once you go to 204. You got me on the next one there. Drop amps, that is. Yes, those are always going to be a problem out there for you.
Yeah, that also affects your spectrum allocation as well, because if you do an OFDMA block from, say, 65 to 100 megahertz, and you cross over that 85 megahertz boundary with one block, that modem that cuts off at 85, it can't just say, hey, I could use half a block.
Right.
That's not how it works. So you might even allocate your spectrum knowing you're going to have some that are cut off. Like 5 to 42, just allocate it to single carrier QAM. Just be done with it. Use it for legacy. 42 to 85 might be a smaller OFDMA block, knowing that some modems that only go to 85 megahertz could utilize it. So at least they can utilize some of it. But if you try to cross over those imaginary boundaries where some of these devices cut off, it's going to make that spectrum unusable. The whole channel will be unusable for that modem. Because there was talk in the industry and cable labs to allow this idea of like a half of a burst. Like instead of bursting 96 megahertz OFDMA with single carrier QAM, the modem, the CMTS would know that modem was only good to 85. So it's like, all right, I'll schedule on these mini slots up to 85. Yeah. So almost like give it half of a. So it wasn't partial mode, but it was like a partial channel, which never really was part of the spec.
Yeah.
And then some people looked at doing it. I don't know. I keep reverting back to keep it simple, stupid. And now we're not keeping it simple, right? We're trying to make things more complex.
I think cable operators just have to be aware, keep in mind, you're going to have house amps that only go to 42 megahertz. You're going to have sections of your plant that you probably forgot to upgrade to from 42 or from 85, etc. So, as you do this migration, just plan to have, as you said, I think you called them imaginary breakpoints, John, of 42, 85, etc., where don't have your OFDMA channel spanning across 42 or 85 megahertz, because it's going to cause some subscribers or groups of subscribers to have problems. So just plan for that. And I've seen, these are lessons learned. I've seen other cable operators do and learn from, because they had these same problems. So keep it in mind. It's going to be a problem.
People might avoid 88 to 108 because of FM ingress, FM radio. So that 20 megahertz, I'm like, it's not worth me throwing a channel in there. And it might be worth it with PMA, being able to monitor and just change modulation if the FM does create ingress.
Yep. Or
some people might just avoid it.
Okay, so the meat and potatoes of SCTE TechExpo, I think, comes from the technical papers. You can find the technical papers at nctatechnicalpapers.com. All of them are there from this year all the way back I think for the last 30 years of technical papers are on that site. It may not be 30 years, but it's a lot of technical papers that are on there. John, I know you looked at, you have some technical papers that you want to talk about, and there's one in particular that I really, really like that I want to talk about. How do you want to start on that, John? You want to cover one of yours, or cover some of yours?
Yeah, I was more focused looking at the presentations and sitting on ones that I thought were interesting, looking at the abstracts and all that, more on the wireline, because I'm a cable guy, I'm a DOCSIS guy. I wanted to see,
we're 5-layer people.
As soon as it said AI, I'm like, I don't have time for AI. I got enough artificial intelligence in my own head. So I was like, let me focus on the stuff I do know and see if there's anything new that would jump out at me. So I wrote down some of the ones, and on here you can see the numbers. Wireline 001, yep. Paper number 6348, John Hong of Cox. That was interesting. That was actually, he presented it in not the loft, but the tech talks, where on the show floor. I sat in on that, and I thought it was interesting because, one, it wasn't just Comcast, because there's a lot of papers from Comcast, but this one was from a guy from Cox that, when I worked with Cisco, we dealt with these guys a lot on the SIN, the Converged Interconnect Network, the digital plant when they upgraded from analog fiber nodes to digital fiber nodes. And that SIN, that digital network, there's some things that have to be taken into account. And a lot of people thought, well, once that Metro Ethernet is up, I could pull a node from, say, San Diego into a node from Atlanta and put them into the same service group, in theory, because it's a digital network and I could have nodes sharing a MAC domain, if you will.
Right.
But we talked about how asymmetrical upstream downstream paths will create havoc on your delay and latency. And then pulling multiple nodes in with different SYN delay, you're only as good as your weakest link. So the shorter node is going to be penalized by the longer node or the farther node. And And I say farther node because sometimes it's not really that far away, but there could be a lot of devices in between creating delay.
Yep.
So I'm not even thinking about distance. I'm thinking about delay. If I do delay from point A to point B, it could be 5 times worse than point A to point C, or, so there are some considerations there about that SIN and how you architect your plant.
And in the paper that I'm going to cover on Rogers, that was one of the lessons learned on the SIN was first you got to have really good optics on. You got to have like 100 gig optics, and those 100 gig optics are not cheap. They're not easy to get. They're and they have to be working well. So the SIN was an area of, I would say, lessons learned that the Rogers paper kind of really focused on. That is not something the cable operators have really had to deal with on a typical basis. 100 gig, really low latency aspects of the network. So the SIN can be very problematic for any type of network, particularly a vCMTS.
Yeah, and just looking at hypothetically, like plan for the worst, hope for the best. Look at all your paths. Say, all right, what's my secondary plan B if plan A breaks? Like,
it has to be redundancy. You have to have a redundant network for that SIN.
And know that path, right? And then you think, all right, if that changes over, some of the protocols I run in the background are there timers that are very sensitive.
Your PTP clock, DHCP, all that has to, if you go, it's basically like a loop. You're going to have a primary SIN going to your fiber nodes, and then you're going to have your redundant SIN, your redundant fiber going to the other way. So if your primary gets cut, everything on your secondary has to work exactly the same way it does on your primary. And it's oftentimes that secondary is oftentimes overlooked. So your primary fails, you go back to your secondary, and the network doesn't work. Or maybe it works at half speed or a quarter speed or a tenth of speed because you don't have things provisioned properly. And so lots of issues can happen on that redundant route.
Even case in point, that first presentation was interesting about, I think they were doing a mesh type of architecture. They said, well, there's so many different paths, everything has to know the next device over. And then they end up evolving to like maybe an aggregate router, something that was smart enough to keep track of all the other guys instead of everybody keeping track of everybody else. Yep. So it's just creating more tables and more lookups and more memory storage and a bunch of other stuff. But I think I like these ones that say lessons learned, because they did learn something from it and they changed up how
they were burned in doing it.
Yeah.
Noisy Endo 1 says, I've been hearing developments like 100G coherent PON. I don't think that's coming anytime soon, at least for cable operators. So coherent optics is something that I don't think it's restricted to just cable labs. Coherent optics is something that it's a thing in the industry, our industry, as well as adjacent industries. But it allows us, instead of just turning light off and on like binary, we actually modulate the light like 16 QAM, 32 QAM, 64 QAM. We're doing modulation over fiber to get the speeds higher and higher, and that is coherent optics. It is a cool technology. I don't know what the timeline is on it, but it's going to allow us, we keep pushing DOCSIS forward and forward. We have to do the same thing for optics, because we know 10 years from now, the speed of optics of just PON networks are going to just be out of sight. So coherent optics allows us to get there. So yeah, Noisy Endo 1, that is a thing. It's coming. I won't say soon, but it's coming.
So. And wasn't there a consortium that got together to talk about the wavelengths and when you do dense wavelength division multiplexing, DWDM?
There is, but I don't recall it right now. Maybe someone in the chat room will tell us what that consortium.
Yeah, which wavelengths actually made sense? Because when we talk about CSO and CTB and distortions, and if you know how things intermix and create distortions, if you pick the right frequencies, in this case wavelengths, you can avoid certain problems.
Yeah.
And I knew there was a consortium of people got together and say, all right, if we all get together and focus on these wavelengths and we all support it, then we can make something that's more reliable, I guess.
Yeah, Dr. Alberto Campos, who works at Cable Labs, who is working on coherent optics, says that problems that we have in different orders of modulations in cable networks, those are going to transfer into coherent optics, and we'll need new test methods to be able to manage modulation profiles and things like PMA. We'll need that in coherent optics when we get there, because we're gonna have new problems. A dirty connector that doesn't impact on-off lighting in fiber today, that same dirty connector is going to have dramatic impacts when we're trying to do high levels of modulation in coherent optics. Back to wireline, John.
So yeah, I'll try to move it a little bit quicker. Dr. Robert Howell, he's always has a dry sense of humor. I like the way he talks about some of this stuff. But there was a lot of papers from Comcast. The only issue I kind of have with the Comcast papers on FDX is, how does that translate for everybody else? Right. What if no one else is doing FDX? If you showcase your test equipment or your ideas on FDX, how do I translate that to everybody else? Or how can I use that? How can I exploit that for myself, right?
Right.
So I think some of the stuff they will sell off to other vendors, right? Like their X1 box, or they because Comcast now is not just they're not just an MSO, right? They're
well,
a vendor.
and Comcast made an announcement that they're going to be syndicating equipment. And I don't know what the extent. It'd be great to hear from the Rogers folks. I don't know if they can reply in the chat. What does it mean that Rogers is now going to be syndicating? Because a big press release. This is out there for the public. More equipment and products and things like that. They already syndicates modems and things like that to Rogers. But now it sounds like it's going to be amplifiers and a whole lot more. And I want to understand what that whole lot more means. Does it mean it's going to be FDX? Is Rogers going to be going FDX now? Or are they still going to be going ESD and just getting modems and amplifiers, and also test equipment? Are they going to be getting test equipment? Are they going to be getting software from them? P&M software, who knows? I'm very curious what this new and this press release means from Comcast and Rogers. That could really expand their FDX footprint if that means that now Rogers is going to go all FDX following Comcast.
Even the number 3 one was the smart amp, instead of just calling it a smart amp, a brilliant amp, and it could be where it's FDX and ESD capable, but having echo cancellation in there gives me more visibility, almost like using the amplifier and node, how we use P&M.
Sure. Yes, because the echo cancellation, actually it's not the echo cancellation itself, but if you take, it's kind of like the pre-equalizer. If you take the results of the pre-equalizer, you can extract what impairments you have. If you take the results of the echo canceller, of what the echo canceller is actually canceling, then you can say, oh, I have these impairments, or I have a tap 50 feet away from me, or I have an amplifier. It can kind of tell you not only what impairments you have, but what devices you have in a plant, because the echo canceller is seeing reflections from those devices in the plant. You can learn a lot about your plant from echo cancellers. So that could be really cool technology. It is pushing state-of-the-art technology, but we can learn a lot from it.
Yeah, the fourth one, Dr. Richard Proden, really brilliant guy. I mean, he's been in the industry forever, and I think he was with Broadcom at one time. Labs at one time, and yeah. So we talked about this thing called water filling. He went into calculations and stuff that it was probably difficult to digest just sitting there. But from the gist, from what I got, was rob Peter to pay Paul, which meant if I do start opening up my upstream spectrum and I start doing, say, let's just take an argument, 4 OFDMA blocks. And I know in the cable plant, there's more attenuation at the higher frequency. So because of the total composite power limitations of the modem, transmit power, and that loss in the coax and all this other stuff, that higher frequency upstream channel could have a worse MER because it's already maxed out in power. I can't raise the power higher to get better carry to noise ratio. So it is what it is, right? Hits the CMTS at 0. Here's the noise floor. There's my carrier noise for basically everybody. But what if you still have power in the modem for the lower frequencies? Those lower the channels in the lower frequency might transmit 40 dBmV, and you're like, well, God, I still got like 10 dB more. I could raise it up and get 10 dB better MER. So why not run those lower frequency channels at a higher level and get a better MER and let PMA throw a new mod profile to it to do
Exactly.
4K quality. So, and I see what the point is, and I boiled this down. It was pretty deep, and I'm like, okay, I'm going to boil it down to one sentence. I'm going to set the channels on the CMTS, upstream channel 0 to +6, upstream channel 1 +3, upstream channel 2 0, upstream channel 3 -2 -3. So you get the point is I'm going to force the modems to transmit different levels by setting the CMTS.
Right.
But his idea was machine learning, AI, more complexity, but it would be more precise.
Yeah,
But
because
now
you don't want to have to
that's-
sit in front of the CMTS and configure each channel, and then when plant conditions change, go back and reconfigure each channel. You want to automate that, and whether that's AI or machine learning or just an algorithm, you're going to let a computer do that for you.
And for the longest time, we've always set the CMTS to 0 dBm V receive, because that was what we always had default, 0.
Yeah.
So the modem puts out whatever it needs to hit the CMTS at 0, or RPD, which really is the upstream chipset. But the idea is, should we revisit that? Could we revisit that? Could we make it better? And we probably could.
Yeah,
we probably could. And on the flip side of that, it's what I've been promoting is to achieve that same thing. Instead of the modems having to transmit a tilted level to go through that coax, hit the CMTS at 0, why don't I start installing conditioned taps?
Yeah, but you're going to want to put F connectors on all those taps too. All right, got some more in the chat here. Yeah, Grab a Sandwich says, giant media corporations that happen to own telecom infrastructure. So we do have a lot of that going on. Jason Roop says, Prodan's paper is excellent, as always the case. By the way, not all the Tech Expo papers are posted on the NCTA site yet. I did not know that, Jason. Thanks for letting me know. Some not there yet. Good to know. It won't require AI or ML. I think he's referring to this, to Prodan's paper that you were just talking about, John. We know the engineering solution. The trick is solving the telemetry and control problems. So that's good to know, Jason. Thanks for the additional input on that. So optimizing things there. All right, John, we got to get rolling here. We're down to like 15 minutes rolling up on these papers here. You got a lot more papers there. John, let me jump ahead of my paper, and then I'll let you get back because I want to cover some of these. I think these lessons learned from the Rogers paper were really, really good. I know Derek Lee, good, awesome guy at Rogers. So Rogers started evaluating virtual CCAP in 2019, and they kept they were in production trials since 2020, and I think they have a lot of nice lessons learned and some other things that they talked about. They introduced this as an interim step between 3.1 and 4.0. So I mean, their goal was to get to 4.0, but they did the 3.1 extended. So increasing the OFDMA channels from 2 to 4 or 5, depending on the CMTS platform. They had different multiple vCMTS vendors that they were using, and the primary objective here is to defer the high upgrade costs for basically going to DOCSIS 4.0 or even having to go to fiber to the curve or fiber, basically PON networks. And I'm glad I like this paper because a lot of our listeners are always like, why doesn't all cable operators just go PON, PON, PON? And they go into this. They did this analysis in their paper. Taking the leap directly from DOCSIS 3.1 to PON will have significant upfront capital costs, but it supports symmetrical multi-gig bandwidth immediately, and this is the XGS PON provides symmetrical 10 gigabits per second of bandwidth. It's actually 8.6 payload because you have 10 gig as the overhead. 8.6 absolute is what the subscriber is going to see. Going PON also represents a significant shift in operational model and requires time and resources in and making it work for the PON access technology. Meaning, this is it's a paradigm shift for the cable operator because all the majority of the techs are trained up on cable and also their infrastructure is as well. So the drivers for DOCSIS 4.0. They say naturally as MSOs consider their options in the next step of access network modernization, we should objectively compare 4.0 to DOCSIS 3.1 extended. Cost. In our cost analysis, we find that despite per home cost of fiber to the home has come down in the past decade, it still costs significantly more to upgrade most homes with fiber to the home compared to distributed access architecture in the Canadian market. So I mean, they're doing this. They've done the analysis, and still DOCSIS is more cost effective than fiber. Legacy video service.
It says 5 to 7 times higher at
Yes.
the very end of the paragraph.
Yeah, it's not trivial.
And on top of that, if you go PON, you basically got rid of all your MPEG-2 and analog video.
Well, that's the next part that they added on to this. I mean, so just saying we're going to go all PON is going to cost us 5 to 7 times more. Now on top of that, they get into the legacy video part. You can't carry legacy video on the PON network. So they'd have to get rid of all their set-top boxes, all their legacy video. On a virtual CCAP, it is compatible with our QAM-based legacy video services. And the virtual CCAP has the ability to carry legacy video services in the head end, similar to an ICMTS architecture. So in the long run, MSOs will likely need to fully migrate, and they're basically acknowledging that in the long run, MSOs will likely need to fully migrate legacy TV to IPTV and reclaim the spectrum and maximize broadband internet. They're basically saying we're going to have to get rid of legacy video because everyone's going to, everyone wants more and more data. That long term will pave the way for fiber to the home, getting rid of that legacy video. Virtual CCAP application is extremely CPU processing power and memory resource intensive and may not and it's not very efficient to share the hardware resources with other network applications. It requires multiple 100 gigabit per second I/O interfaces. I mentioned this earlier when you were talking about the SYN, John, which is expensive and very uncommon. And then this is the redundant part. We talked about the primary and secondary loop. For server redundancy, virtual CCAP applications often require servers to be configured in clusters for multiple physical servers. As of 2024, most virtual CCAP platforms are containerized that run on bare metal servers and do not support any type of hypervisors. That's a challenge for most cable operators. Most cable operators today, they like to virtualize things. They don't like to install things directly on bare metal. I've run, as a software vendor, I've run on this as myself. Everything we have is containerized. We'd like to install it on bare metal, but cable operators are not open to that. I like the last paragraph, though. At present time, Rogers considers standardized containers on bare metal servers is the right architecture for virtual CCAP applications. And they're going to be looking at this as a future, something that they will start doing and supporting, installing containers on bare metal. Timing and synchronization. This is the Achilles heel for vCMTSs, in my opinion, with my own personal experience. I've had a lot of issues with this. They talk about this here. DOCSIS standard requires that for remote PHY architectures, tight, and I mean very, very tight here, tight PTP, precision timing protocol signal synchronization must be maintained between the CMTS core and the RPD. The RPD is your fiber node that goes out in the field. Could be a long distance away. As a result, virtual CCAP core typically has a synchronization holdover limit of 30 minutes instead of the 1 to 2 hours. So if you lose that PTP clock, your fiber node's going to go down within 30 minutes. Versus if this was an ICMTS or something, you know, if that clock in the ICMTS really never goes out, right? It always stays on. So your fiber node always stays up. For Rogers, and I think for any cable operator, this is a very important architectural consideration because timing synchronization loss cannot be caused by physical defects such as cable cuts. So it can be caused by losing the GPS antenna, but more often it's caused by logical disconnections such as failure of your router, PTP signal slow. It can also be caused by network defects, like your firewall going out, the network cable being disconnected. And when that happens, all your subscribers, like 100 to 200,000 subscribers, can go offline. So that is not trivial. I mean, that's significant for the cable operator to have that type of loss. Geo redundancy. So this is you need to have, if your head end goes down, all the subscribers on that go down at the same time. So you want to have redundancy for your CMTSs. They talk about how you can do that, and they talk about the term of blast radius. And I actually heard blast radius is my first time. at SCTE Expo this year. I was doing searches to see the first time it was mentioned in the cable industry, and there was a paper last year also by Rogers that mentioned the blast radius. And the blast radius is just if there's a problem, how many subscribers are knocked out. So we were talking about this when we were talking with a company about why MACPHY might be better than vCMTSs, because MACPHY is just one fiber node impacting maybe 100 or 200 subscribers. Whereas vMCTS, like an iCMTS, if that goes out, that can take out a lot more subscribers. And we're seeing vendors maybe tie even what Rogers is doing here is saying they're tying 200 to 300,000 subscribers to a single vCMTS. That's a lot of subscribers on a single vCMTS. So that vCMTS goes down. What they're saying is that blast radius is huge. You have a lot of subscribers. That's a big outage. So when we get into their lessons learned, I'll wrap this up pretty quick here. They're saying that the savings in power space, the head-end space savings was 75%, and the power savings was 14%. I was actually quite surprised by that because I think I had been part of a presentation a few years ago that indicated the power savings was a bit more than that. But I believe what they're saying because they actually did this. They applied it. They didn't actually just do the math. So this savings is important because with the increased capacity demand from CAGR, so they actually believe the head-end savings is more valuable because as traffic growth increases and subscriber growth increases, many CMTS hub sites cannot scale with the growth in CMTS capacity and would require major facility expansion to support power and space requirements.
I suspect the power savings was also getting rid of video QAMs, because that could be racks and racks of video QAMs that you don't need anymore because the remote PHY is generating the QAMs out in the field.
Yeah, and we know that from earlier they indicated they were still maintaining their video QAM, so they're doing a hybrid IP and video QAM solution. So they didn't realize that video QAM power savings. Yeah. Shift in support model. If there's any defect or deficiency with the CMT, and I've seen this before with a customer, the service provider would obtain support from CMTS vendor regardless if it is, so this is legacy, this is your existing bare metal CMTS. Anything happens with your bare metal CMTS, your vendor's going to cover it. In the virtualized CMTS, this is not necessarily so straightforward anymore. Defect diagnostic becomes a lot more complicated, and bug fix or system recovery can easily turn into a finger-pointing exercise and difficult to hold a single party responsible. So that can be a problem for an operator. A tier 1 operator probably has a lot more pull. A tier 2 or tier 3 operator is going to be a bit more of a pickle when that finger pointing starts, because it's going to be like, oh no, it's a physical plant problem. No, it's a CMTS problem. We can see how those can really explode. Compatibility with legacy video and legacy services. So we talk, video, our standard MPEG video, we can transport across it, but analog video, absolutely not. Any out-of-band command and control, plant leakage equipment, things like that, those are not going to be supported on a vCMTS, and they basically just go away, and you have to come up with new solutions for them. So those are problematic solutions. So the conclusion I thought was nice. They wrote this up well. Virtual CMTS is a cutting-edge technology and is an essential enabler for DOCSIS 4.0. With this new technology, it requires the cable operator to make architectural decisions and also offers new architectural options with its own pros, cons, and challenges. This paper shared some of the technical evaluations and directions that Rogers has made on our journey of vCMTS assessment, lab evaluation to field trial, and together with some operations lessons learned during our field trials. Compared to evolution through previous DOCSIS generations, DOCSIS 4 represents a much bigger network and operational transformation to MSOs. The intent is that by sharing our experiences, we can be beneficial to other MSOs who are navigating their paths through virtual CMTSs as well. We also hope that it encourages the MSOs and cable industry to collaborate tighter relationships among the MSOs and vendor communities along this exciting journey. So that, I think, is a point we all take together. This is not an easy journey. Rogers definitely learned some things, and I'm so grateful that they took the time to share the lessons learned. This was a great paper. I definitely recommend it to others. I only covered some of what the lessons were learned in here and some of the details, but there was a lot, and a lot that I learned by reading this paper, and a lot of great other papers in here too. But I think as an industry, we got to continue the sharing, because the complexity that we're in right now as we go, whether it's ESD or FDX, and we're going to 1.2, 1.8, and 3 gigahertz, we are going to have a lot more lessons learned coming down the pike, and that the more we share, the better we're going to be on that. So a lot going on there, John.
Yeah. The one thing I just learned. That must be a Canadian word. Learned.
So
the other thing that came up a lot was the extension of the plant. Could we go further than 1.8, 3 gigahertz? There was talk about 5 gigahertz, and I'm sure the coax can go there, but we'd have to get shorter and shorter coax. We all know we're going to have to get fiber as deep as we can. So the fiber gets deeper and deeper, fine. We talked about going GPON at some point, but that last 100 feet through the customer's lawn into their house could be more expensive than you really think.
It's right? The most expensive. The drop is the most expensive part with fiber.
Yeah. So if you're still trying to hold on to legacy set-top boxes, stuff like that, I could envision RPD being in a tap. So the only coax you have is the drop cable.
Yep.
And then if that's the case, then yeah, maybe the drop cable could support 5 gigahertz because I'm only going 100 feet, but all the other coax is gone. So there definitely will be some decisions made where your pros and cons, like at what point do I rip it all out and just go fiber all the way in? That's a business decision, right?
Every cable operators, I'm sure, looking at that from a business decision standpoint. So let's see, we got Noisy Ando says, apparently it's harder to do 50 GPON symmetrical at the moment. When I got fiber to the home installed, I actually had cable TV with it for a little while, but then we went to IPTV eventually. We got Roku over-the-top boxes. And Jason Roop says, I suspect the NCTA site will have all the papers soon. Thank you, Jason.
Yeah, that's a great spot to hold all those papers. I mean, a lot of papers. Yeah, I was on the committee to review some of the papers, and my own paper got dissed. My own paper didn't get accepted. But I mentioned to Dean Stoneback, I said, for everyone that even submitted a paper, if they didn't get accepted, we should have still put it in that, what do you want to call it, repository? Just to have them all there. So if someone's willing to write a paper, even if they don't have a chance to present it at the expo, why not put it there just so people can read it, Just add more information. Still there?
Yep. No, I think, we used to get books. We used to get big, thick books, but and those you couldn't search. Being able to go on there and search those PDFs is just absolutely fantastic. So, John, was there more that you wanted to cover from the wireline track from the page 2? Anything you wanted to pick out here?
Let's see, Larry Walcott, number 10.
Oh, that was the one I moderated. That was really a good one. So Larry was I don't know if you want to cover it.
When you think about it, a 6.4 megahertz ATDMA upstream channel, 6.4 megahertz, it has a 24 tap equalizer. My analogy there is like 24 sampling points. So if you did a standing wave with 24 sampling points, you'd really have 12 standing waves, right? Up, down, up, down, up, down. So doing the math on that, you can figure out what's the farthest distance a cavity could be, knowing the granularity of a 6.4 with that 24 tap equalizer. And we knew what that was. But now with OFDMA, heck, we could have subcarriers every 25 kilohertz.
Yes.
We could have such a tight standing wave and do the math. We could say there's a problem 800 feet away, or there's a cavity that's 800 feet distance, between a tap and a housing. So just knowing the subcarrier spacing in OFDMA and going from 3.0 to 3.1 with OFDMA, and even OFDM on downstream, we can pinpoint problems even sharper, like where the problem is, or really narrow down how big the cavity is. Then we look at our plant map and say, well, the only logical spot is these two taps are exactly 530 13 feet, apart or something like that.
I'm so with you, and I kind of felt like Larry's paper was a mic drop moment because he kind of took us through how pre-equalization has worked for P&M, and it's like, well, we can get within 50 feet of accuracy, and now with OFDMA, we can get within 3 feet of accuracy, and you can just dig right here. And because we always told people, don't, when we tell you there's a correlation group here, don't go dig a ditch because it's only a 50 feet accuracy. But OFDMA just blows it out of the water, and it was an awesome presentation.
I thought number 11, he was on your panel as well, Bilal.
Wow! Oh yeah. He
because I've done a lot of math on the upstream power level issues, 65 dBmV, dynamic range window, all these little issues I think are going to creep up when we go past 204 megahertz upstream. Some of the fixes for that were condition taps, but controlling the power level of the upstream channels. And he kind of went down the idea of I could control which upstream bonding groups a modem uses to still get what he's paying for, but by limiting the number of upstream channels he uses, not just haphazardly saying just use it all.
Right.
I could control his total composite power.
Yes, tier-based bonding. So give the right channels to the subscriber based on the tiers that they're using. So it's really focused on that.
And the other thing that came out of that, I didn't realize in DOCSIS 4.0, they broke up that 65 dBmV total power to say we want below 85 megahertz legacy to be below 55 dBmV total power, and above there would be 64.5.
Right.
And if you add those two up, it ends up being 65.
Which is your max trans. That's a max your modem can put out.
Exactly. So
I mean, really, if you're smart about it, your modem could probably be transmitting at max power just about all the time to get your optimal RxMER for your channels.
And then the very last one, Mike Odell, he went over, and I've harped on this a lot. Just because the modem's online, all the features in the modem and CMTS could be masking problems.
Correct.
So it could be in partial mode and you don't even know it, and the customer is complaining about speed because he's not bonding on all the channels he should be, or he's running a lower modulation scheme. So to proactively monitor all the devices, say, here's your capability, but here's what you're doing. Here's your modulation. I really wish you were doing 4K QAM, but you're only doing 512. Say, no wonder your latency is so bad. No wonder your speed is so bad. So, but to monitor all those devices, and you could cluster them, and then that would help you figure out where the problems are, or there is a potential problem coming up.
So, I think that's when Mike was talking about that, whether or not your modem, whether or not your DOCSIS 3.1 modem is even bonded to the OFDMA or OFDM channel. Some cable operators they're not even looking at that. They're turning up OFDMA and putting a bunch of 3.1 modems out and hoping the 3.1 modems are bonded. They'll look when they first deploy them and say, oh, great, the modem's locked to the OFDMA channel, but then they're not looking afterwards and seeing how often that modem is dropping from the OFDMA channel. And that's just lost capacity. It's a wasted 3.1 modem out there. And that's part of what we do with our PMA application, the profile management application, is we monitor the modems and we change the profiles to ensure 3.1 modems remain locked to the OFDMA and OFDM channels. So if they're not locked, you're not getting any of the advantage of a 3.1 modem. It's just a 3.0 modem. So those are three. That was a great panel with Larry, Bilal, and Mike Odell, because they kind of covered all aspects of where we went from the early days of DOCSIS 3.0 and pre-equalization to now doing looking at all the different metrics with Mike Odell, and Bilal following it up with doing tier-based bonding to just extrapolate the most you can out of each service group for your subscribers. So it was a great expo. I got a lot out of it. I would say this was the first one we actually see lots of 4.0 equipment. Vendors are saying they're shipping the equipment out. I don't know, probably it's all the tier 1 operators right now. If you're a tier 2, you may not get access to it, but that equipment is there. We got to see a lot of demos, talked to a lot of people about it, and also amplifiers, 1.8 gigahertz amplifiers, even some 3 gig equipment out there. It's there. It's live. It's real, Joe.
I would throw out to anyone that's listening here today or online to pull down some of these papers, read it yourself, get back to us, and maybe we can dive deeper into it. Maybe even pull in the author of that paper and go over, do it justice, right? I mean, when you're in the workshop, you don't have much time to really go into depth and what you're really talking about. Even the one in the middle there from Yvonne, he works at Technetics, and that's still, we're pushing that idea of this is a paradigm shift. I don't like to use that word too much. Paradigm
Powering.
shift.
Yep.
Powering and saving up to 30% power by not going to DC on my mainline power supply, but going almost DC. So instead of quasi square wave 60 hertz like we normally do with ferro resonant power supplies, but going to a 3 to 10 hertz. So it's direct current, drop it, switch it, come back up. So it's alternating current, but so slow that it's, some people call it switched digital, or switched whatever. I'm like, that's kind of an oxymoron, right?
There's no 60 hertz anymore.
Yeah, it's not
bye 60
anymore.
hertz.
Exactly. But it was kind of interesting. And the fact that you could change out the main power supply and existing power packs and amplifiers could still use it.
Yep.
You didn't have to change anything in the field. They could actually utilize that. And by doing that, your I squared R losses through the coax cable drop. So when a constant wattage amplifier needs a certain wattage and you can hit it with a certain voltage, there's less current. If there's less current, there's less voltage drop. So it's really a snowball effect when you have voltage drops on how that really drains your entire power network. So, I mean, there's some interesting ideas there.
All right. So some general thoughts then is common theme. Comcast had a lot of papers. I think they were the lion's share of the papers there. And I think we talked, proprietary functionality of Comcast with FDX and their technology benefit others, and how will it benefit others? I think that's yet to be seen. Yet to be seen how FDX will play out. And we talked how the syndication will play out as well. So Jason Root made a good suggestion about sharing more in the industry. If people have ideas and papers, you can always submit those papers to the SCTE Technical Journal. It doesn't have to be just at SCTE Expo. So Jason, I think that was a great suggestion. Thank you very much. Otherwise, John, great overview, great discussion.
Next year?
SCTE next year. Yes, the indices, subscribe and like, everyone. Thanks. But yeah, SCTE next year is supposed to be in Washington, D.C., and then I've been told after that it's going to alternate between Denver and Atlanta. But what do I know? All right, John. I hope everyone enjoyed the overview we gave of Expo and some of the videos we had. Thanks for tuning in, everyone. Be sure to subscribe and hit that notification bell so you don't miss our next episode. As always, it was great having John Downey here to share your illustrious and amazing insights, John. Until next time, tune in and stay well, everyone. Take care. Thanks, John.
We'll see you.
See ya.